phrase, say on, and now we're keeping that capital letter. So those are just a couple different ways that we could make this program a little bit better. But the basic concept is we have a for loop and then we have some if loops inside of it, and we're calling this awesome function that can translate a word for us. In this tutorial, I want to talk to you guys about comments in Python. This is going to be a pretty short tutorial. I just want to give you guys an overview of what comments are and how we can use them in our Python programs. So over here in my Python program, I just have this line here. It says print comments are fun. So if I run my program down here inside of the console, it's going to print out comments are fun, right? So any code that I put over here is going to get executed by Python. But there's actually a special line of code that we can write, and it's called a comment. And a comment is basically a line inside of our Python file that's just not going to get rendered by Python. So when Python sees it, it's just going to ignore it. It's not going to execute it. It's not going to print anything out. It's just going to kind of ignore it. And comments are basically just used for us humans. So a comment is used for like me or another developer to write a little comment, a little like plain text, comment inside of a file. So in order to create a comment, I could use this hashtag symbol. So I can click hashtag, and now I am writing a comment. So I can write whatever I wanted in here. I could say like, this program is cool. And you'll notice when I run the program, that doesn't show up anywhere, right? It doesn't matter what I put after this hashtag. This is just like ignored by Python. It's just for me or another developer to come in here and use. So a lot of times if you want to write like a little note inside of your Python files, or maybe you can write yourself a little reminder, or if you want to write a line to like explain a line of code. So for example, I could write a comment that would explain this print statement. So I could say like, this prints out a string, right? Now anybody looking at my file would be able to read this and they'd be like, oh, that's what this does. Okay, cool. So comments are useful for leaving little comments in a Python file. If you want to make comments on multiple lines, you can just create a new line and use another hashtag. And so then I could type out whatever my next comment was. And generally, if you're going to put comments on multiple lines, you want to just use multiple hashtags. But there's actually another way that you can write out comments. So you can use a triple quotation mark. So I'm typing out the single quote, and I'm typing it out 3 times. So you can see here, up here we have this 3 times, we have this 3 times. So in here I can, write any comment that I wanted. So I could put, as much text up here as I would want. And same thing, when I run this program, it's just not going to get rendered. So this is another way to make multiple line comments. But the official Python style guides or whatever just recommends that if you're going to put comments on multiple lines, you use these hashtags. So you can really do whatever you want, but if you want to be super Python official, then use these hashtags. Comments can also be useful for doing something called commenting out a line of code. A lot of times when you're writing a program, you might have a line of code in there that is maybe potentially messing stuff up. And so what you can do is you can actually comment out that line of code. So I could put a comment in front of this line of code, and now when I run my program, the program's going to run, but it's not going to use this line. So sometimes if you're trying to see if a line of code is causing you trouble, or if you want to see what your program would be like without a line of code, or even a block of code, you can just comment it out. And that way you're not actually deleting the code from your file, you're just commenting it out. So Python's going to ignore it. And those are really the 2 uses for comments. It's to write little notes, write little comments about different things, or to comment out code. And as you go forward in Python, I'm sure you'll find uses for comments. In this tutorial, I want to talk to you guys about catching errors in Python. Now, a lot of times when we're writing Python programs, you'll encounter different errors. So different situations could come up and your program might throw an error, or it might throw an exception. And a lot of times when these situations happen, they'll completely stop your program from running. And what we can actually do is we can watch out for certain specific errors that are going to pop up in our program, and we can actually handle them. So instead of our program just breaking and stop executing, we can actually handle those errors and do things when they occur. So I want to show you guys an example of using this. Down here I'm saying number is equal to int input enter a number. Basically what's happening is I'm prompting the user to enter in a number using this input command, and then I'm converting whatever they entered into an integer. So as long as they enter in like a valid integer, I can convert it into an integer. So I can convert it into like a whole number, and I can store it inside of this number variable. Then I'm just printing it out. So let's try to execute this program. I'm gonna run the program, and you'll see down here it says enter a number. So we can enter in like 4, for example. And when I enter in 4, everything's gonna work, and it's just gonna print out 4, and everything is right in the world. And actually I'm gonna modify this up here so it's a little easier to see. But let's say we run the program again. So it says, okay, enter your number. Let's say that I break the rules and I don't enter a number. So I just ignore what the prompt says and I put, some random text in here. Now when I enter this, the program's gonna throw an error. You can see down here it says value error, invalid literal for int base with base 10. Basically, hey, you didn't enter in an integer like you said you would, right? We told them to enter in a number, they entered in text, so it broke the program. And this is a situation that happens a lot. So there's a lot of different situations where something can just go wrong in our program. And up until now, we've just kind of accepted it as a reality. But if you're writing a real live Python program, you don't want something like this to trip up your program. You don't want the entire program to break when somebody just forgets to enter in a number, right? You want to be able to handle all these different situations. And in order to handle them, we can use something called a try except block. And a try except block will basically allow your program to try out a piece of code, and if everything goes well, then we're great. Like, we could try out entering in the number, and if the user enters in the correct number, great. But if they don't enter in the correct number, then we can basically like account for that. So if they entered in something like a string when they're supposed to enter in a number, we could tell them like, hey, you entered in the wrong thing. So I'm gonna show you guys how we can use these try except blocks. I'm gonna come up here, and I'm just gonna say try. I'm gonna make a colon, and now I want to indent both of these things. So both of these things are gonna be inside of this try block. Now I'm gonna make a new line. I'm gonna come down here, and I'm just gonna type out except. And I'm also gonna put a colon here. And down here, I'm just gonna print something out, so I'll just say like invalid input. So now, since I put this code inside of this try block, if the user enters in something wrong, it's gonna be able to catch it. So it'll be able to catch what the user does wrong and print out invalid input onto the screen. So let's go ahead and run our program. And it's just gonna say enter a number. So we're gonna ignore that. We'll enter this in. And now instead of yelling at us and breaking the program, it just says, hey, invalid input. So it was able to handle the error that got called. It was able to handle the invalid input error. Basically just told us, hey, no more input. So this is a really powerful thing that we can do in our Python programs, basically just to protect our programs, right? If I want to have my program running for long periods of time, I can't have something as simple as an invalid input trip it up. So I can catch that invalid input using these try except blocks. But here's the thing, you'll notice that this little guy down here is getting highlighted. And let's just see what it has to say. So it's basically saying too broad exception clause. And this is a message that we're getting because when I just say except, this will catch any error under the sun. So anything that can go wrong in my program, for the most part, this is gonna accept it. So let me give you guys an example. Let's say I had in my program, I was creating a variable, right? So I wanted to create a variable called value, and I set it equal to 10 divided by 0. Now, if you know anything about math, you'll know that you can't divide a number by 0. It's not possible. So the program isn't going to be able to handle this, and you'll see that this is going to throw an error for us. So when I run the program, it basically says 0 division error, division by 0. We're not allowed to do that, right? If I took this and I put this down inside of this try block, and I just pasted it in here, it's gonna get caught by this exception that we wrote down here. So it's gonna get caught by that except. So when I run the program, you'll see it says invalid input. But the problem is that we didn't input something that was invalid, right? We just divided by 0, but it wasn't able to handle that, right? So it could not divide by 0, it threw an error. So even though we didn't get an invalid input, even though it was because we divided by 0, it still printed this out. And this brings me up to another point, is we can actually catch, or we can accept specific types of errors. So for example, in this case, we got a division by 0 error. In this case, we got an invalid input error, right? We put something in that was wrong. It couldn't convert the value. So I can create 2 different except blocks to catch 2 different types of errors. So down here, I can just make a space and I can specify the type of error that I want to catch. So when we divided by 0, it was 0 division error. So if I just put 0 division error in here, now it's going to catch that 0 division error. So I can say divided by 0. I could also make another except, so I could say except, and we can catch the other exception that we got. So I think it was a value error, right? It was, we put in the wrong type of value inside of that input. So now we can print out invalid input. So with these 2 except blocks, we're basically able to handle both of these situations. So for example, if this ends up breaking the program, this division by 0, then it'll be able to catch that. So down here, it'll tell us, hey, you divided by 0. But if I was to get rid of this line of code and I just entered in the number wrong, so I came down here and I entered in a string instead of a number, now it's gonna tell us invalid input. So we're gonna be able to specify what happens when certain things break. So when we get a value error, we can say invalid input. When we get a 0 division error, we can say divided by 0. So depending on what breaks, depending on what happens, we can actually do different things. And I want to show you guys one more thing we can do, which is we can actually store this error as a variable. So I can say except, and I can say as, and I can type in a name here. So a lot of times people will just say like ERR. And down here, I can print out the actual error. So I could just print ERR. And so if we end up dividing by 0, so if I say answer is equal to 10 divided by 0, we're gonna throw this error and it's gonna print out what went wrong. So now I can run this program and it just says division by 0. So it just printed out the error that we got. So that's another useful thing you can do, is you can actually like print out the specific error that got thrown. Now, a best practice in Python is to use these specific errors. So you always want to accept for a specific error. What you don't want to do is just say accept and then just accept anything under the sun. It's just too broad and it's not a good practice in Python. So you always want to be catching specific errors like this. In this tutorial, I want to talk to you guys about reading from external files in Python. Now, a lot of times in Python, you're going to want to read from files that are outside of your Python file. So you might want to read information from like a text file or a CSV file or like an HTML file. And you can actually use something called the Python read command, and it will allow you to read a file that is stored outside of your Python file. So you can use these files to get information, or you can parse through different files and do different things. So I'm going to show you guys the basics of reading files, opening files, closing files, doing all of that stuff. Over here, I have this file called employees.txt. And it basically just lists out a bunch of different employees. Like these could be employees in an office or whatever. So it's just listing out all of this information. So let's say that inside of my app.python file, I wanted to read the employees inside of that file. The first thing I have to do is actually open that file from inside Python. So I can use a special command called open. So I can say open, and then in here, I can type in the name of the file that I want to open. So this is either going to be a relative path to the file, an absolute path to the file, or just the file's name if both files are in the same directory. So in my case, app.python and employees.txt are in the same folder, like they're in the same directory. So I can just type out the name of the file. I can just say employees.txt. And now I want to put one more thing inside of this open function, and it's going to be the mode that I want to open the file in. So you can actually open files in a couple different modes, and the first mode is called read. So I can just put an R here, and that's going to stand for read. And this basically means that I only want to read the information inside the file. I don't want to modify it, I don't want to change it, I just want to read it. I just want to see what's in the file and do some stuff with that information. Another mode is called write. So I can type in this W. And writing basically means that you can change the file, right? You can write new information, you can change existing information. There's another one called A, and A stands for append. And this basically means that you can append information onto the end of the file. So you can't modify any of the information in the file. You can't change any of the information, but you can add new information. And there's one more, which is R+. And this basically means read and write. So this will give you all the power of reading and writing. So in our case, we're just gonna be working with regular R. So we're gonna be reading from the file. Now this open function will essentially just open the file. So it's gonna like go over to that file inside of our file system, open it up, and it'll allow us to read through it. But generally we're gonna wanna store this opened file inside of a variable. So I can create a variable and we can just call it employee file. And I'm just gonna set it equal to this open function. So now the open employees.txt file and all the content inside of it is stored inside of this employee file variable. Now, whenever you open a file, you always want to make sure that you close the file as well. So just like we have this open command, we also have an close function. So I can come down here and say employee file dot close. And this is essentially just going to close the file so we're no longer going to be able to access it. And generally, it's a good idea whenever you're opening up a file, you want to also make sure that you're closing the file at some point. So generally, once you're done reading it, you can just close it. So that's kind of like how we can open and close a file. Now, let's talk about how we can get information from the file, right? There's no point in having the file there if we can't figure out what's in it. So there's actually a few different functions that we can use on this employee file to figure out what's inside of it. And I'm going to show you guys some of those. So I'm just going to make a print statement, and inside this print statement, we'll basically just print out some information about the employee file. So the most basic thing we can print out is just the entire contents of the file. But before I do that, I want to show you guys how you can check to make sure that a file is readable. So before we do anything else, generally it's a good idea to make sure that it's possible to read this file. And there's a function inside of Python we can use called readable. So I'm just going to type out employee file dot readable, and this is going to return a Boolean value, and it's going to tell us whether or not we can read from this file. So I'm going to run my program, and you'll see down here we get a value of true, and that's because we set the file with a read mode. So it's in read mode, we can read from it. If I was to put a W here, so if I put like write, now readable is going to be false because we can no longer read the file, we can only write to the file. So I'm going to change this back to R so we can just read it. So once you figure out whether or not the file can be read from, let's actually read it. So there's another function called employee file.read, and this is basically just going to spit out all the information in the file. So when I run the program, it's just going to spit out all of this information, right? All the information that was in that file. I can also come down here and we could read an individual line inside this file. So I can say employee file.read line. And what this is going to do is it's going to read an individual line inside of this file. So now when I run this program, you'll see it's just reading that first line in the file. And this read line function is actually just reading the first line, and then it's basically like moving a little cursor onto the next line. So if I was to copy this line of code and then print it again down here, I'm saying employee file.readLine, so it's going to read the first line, and then when I say it again, it's going to read the line after that. So this is actually going to end up printing out the first two lines in the file. So when I run this program, you'll see we print out Jim Salesman and Dwight Salesman. So if I was to do this multiple times, like I could technically print out every line inside of this file. And you can see we can do that. And so that can be pretty useful for reading multiple lines in a file, but there's actually another function that is better at doing that. And we can say, instead of employee file.readLine, we can say .readLines. And what this is going to do is it's going to take all of the lines inside of our file and put them inside of an array. And so now when I print this out, you'll see we have this array down here. It says Jim Salesman, that's the first item in the array. Dwight Salesman, the second item in the array. It's basically taking each line and putting it inside of an array. So if I wanted to access a specific line, I can just refer to it by its index in the array. So if I said 1, now this is going to give us that Dwight Salesman line because that is at index position 1 inside of the array. You can also use this read lines function with a for loop. So I could come up here and create a for loop. I'm just going to say for, and we'll say employee in employee file. And then for each employee, we just want to print them out. So, and actually, sorry, we have to put employee file dot read lines up here. And so now this will loop through all of the employees in this employee file dot read lines array. So we can actually just print out the individual employee. And now this will print out all the employees inside of that file. So it's basically printing out each line in the file. And that can be pretty useful. So you can use all of these different functions like read, read line, read lines, readable. You know, there's a bunch of these different things that we can do to get information from a file. And so there's a lot of cases where you're going to want to be able to parse through information in a file, and this is an awesome way to do it. So just to recap, whenever you want to open a file and read from it, you can just use this open function, type in the name of the file and then the mode, which in our case is going to be R. Then you can do all sorts of stuff with it, and you always want to make sure that you close it when you're done. That's just good practice. So that's the basics of reading from files, and hopefully you guys can use this in some way, shape, or form in the future. In this tutorial, I want to talk to you about writing and appending to files in Python. So one of the cool things about Python is it allows you to work with external files. So I could have like an external text file, and I could actually like completely read all of the information in it. I could parse through it, use that information to do certain things. But in addition to reading a file, I could also write a file. And that's what I want to talk to you guys about today, is writing new files and appending onto existing files. Over here, I basically just have some code written out, and this essentially just reads information from this employees.txt file. So you can see over here, I'm specifying the mode, which is R, and that stands for read. And then down here, I'm just reading all of the contents of the file and spitting it out on the screen. So I'm gonna click the play button over here, and you'll see that this executes. So it's printing out all of the lines of code in our text file. So over here, I'm in this employees.txt file, and it just has all this information like employees in an office. But let's say that I wanted to add another employee onto here, right? Let's say that a new employee joined our company, so we wanted to add them onto this list. Well, I can come over here to my app.python file, and instead of reading from the file, I want to append to the file. So I want to say A. And appending to the file basically means that you're adding some text at the end of the file. So wherever the file ends, you're just going to add some text onto there. So what we can do is we can actually add another employee into the file. So instead of printing something out, I'm actually just going to say employee file dot write. And when I say employee file dot write, I'm going to be able to write something to the end of the file. So I can basically just write whatever I want. So why don't we add in another employee into our employees.txt file? So we can add in another employee. Why don't we say like Toby, and he's going to be in human resources. So now when I run this program, it's going to add Toby human resources onto the end of the file. So I'm going to run my program, and you'll see that nothing shows up down here in the console. But if I go over to my employees.txt file, all of a sudden we have a new entry over here. It's Toby from human resources, right? So I was able to append a line onto the end of this file. But here's the thing, you need to be careful when you're writing to files, because you can actually mess up a file very easily. For example, I already added Toby here into my file, but if I was to run this program again, you'll see that over here in this employees.txt file, it went ahead and added Toby again, right? So it added this employee here again. And also you'll notice that in this case, this employee didn't go on to the next line. I accidentally ran my file again, and all of a sudden it messed up this file over here. And so appending, you really need to be careful, because if you accidentally run your file again, or if you append something on something wrong to the file, it's permanent, like it's getting saved inside of the file. So I want to talk to you guys a little bit more about, appending. Another thing we could do, let's say we wanted to add another employee, and you'll notice over here in this employees.txt file, when I appended it on again, it got appended to the end of the existing line, right? So the first time I had a new line there, but if you don't have a new line at the end of your file and you want to add a new line, you're gonna have to add some special characters. So let's add another employee and we'll call her Kelly. And let's just say Kelly is in customer service. So Kelly is gonna be in customer service. And if I want to add this employee onto the end of the file in a new line, I'm gonna have to put a new line character in front of it. So I can say \n, and this will append this entry into the file with a new line, so on a new line. So now when I run this, you'll see we get Kelly from customer service on her own line. So you wanna make sure that you're aware of like these special characters that you can use. They call them escape characters. And anytime you're adding onto a file, you want to make sure that you're adding on exactly where you want to add on. So in addition to appending to a file, I could also just like overwrite a file, or I could write an entirely new file. So since we already have this open, instead of appending to the file, why don't we just write a file? So I'm going to use this W. And now if I say employee file.write, because I'm using W and I'm not using A, it's actually gonna override the entire file, and it's only gonna put this inside the file. So when I run this and we go over to this employees.txt file, you'll see we only have one line inside of this file now. It's just Kelly customer service. That's because I was using W, not A. And when you use W, it's just overwriting everything that's in that existing file. You can also use W to create a new file. So over here, I could say employee file is equal to employees1.txt. And now what's gonna happen is when I run this, it's gonna create another file for me. So I'm gonna run this, and you'll see over here in my file browser, we have this new file, employees1.txt. So if I open this up, it has exactly the same stuff as in this employees file. But it basically created a new file for us. And so a lot of times you're gonna wanna create a new file, and you can use different extensions too. So if I wanted to create like a web page, I could say index.html, and I could also add in some HTML code in here. So if you don't understand HTML, don't worry about it. But if you do, I could put like a paragraph in here, another paragraph, like this is HTML. Basically HTML is like a web page. And the point I'm trying to make is that you could write out a web page inside of Python by doing something like this. So now when I played this, we get this index.html file, and it has some HTML inside of it. So that's one way that writing to files can be really useful. You can overwrite an existing file, you can write a new file and create it, or you can append on to the end of a file. And there's tons of applications for writing to files, and Python's a great language for working with reading, writing, and doing all that stuff with files. In this tutorial, I want to talk to you guys about using modules in Python. Now, a module is essentially just a Python file that we can import into our current Python file. So, for example, if I wrote a Python file that had a bunch of like useful functions or useful variables or other things like that, I could take that file, I could import it into the file I'm currently working on, and I could actually access all of those functions, all of those variables, all the stuff from that external file inside the file that I'm currently working on. So I'm going to show you guys how we can use modules, and then we'll talk about where you can find awesome modules and really why modules make Python an awesome language. So over here in my text editor, I actually created this file, and it's called usefultools.python. And basically this file just has a bunch of sort of like useful tools that I might want to use in one of my programs. So you'll see over here I have some variables. This one is telling me how many feet are in a mile. This one's telling me how many meters are in a kilometer. And then we have this list here which lists out all of the members of the Beatles. I also have a couple different functions down here. So I have this get file extension function. And this basically just will, you give it a file name, it'll tell you what the extension is. And then we have this other function down here which simulates rolling a dice. So you pass it a number. If I pass it like a 6, it would roll a 6-sided dice. If I pass it a 9, it roll a 9-sided dice, etc. So this is like a Python file that I wrote, and it has some useful stuff in it. And honestly, there's a lot of stuff in here that I might want to use in the other Python files that I work with. So let's say I'm over here at this app.python file, and I'm thinking to myself, I think I could use one of those functions that was inside of that useful tools file. Actually, yeah, I need to simulate rolling a dice in my program. Well, instead of having to go over here, copy this function, and then paste it over here into my program, I can actually just import this useful tools file, and I'll be able to import all of these functions and all of these variables and attributes. So the way I can do that is just by coming up here, and I'm just gonna go right at the top of my file, and I'm just gonna say import, and then I wanna type in the name of the file that I wanna import. So I'm just gonna say useful_tools. And Python's gonna be smart enough to know that it should go off and grab all the stuff from this usefultools.py file. So once I've used that import statement, I can actually use all of the functions inside of that useful tools file. So for example, I could simulate rolling a dice. I could say useful tools dot, and now I'm actually able to access all of the attributes from inside that file. So when I say useful tools dot, you'll see down here in my little suggestions menu, it's telling me like Beatles, feet and miles, get file extension, meters and kilometers, roll dice. So it's giving me access to all of the stuff that was in that file. So over here, I could just say like roll dice, and we could pass this like a 10, we'll roll a 10-sided dice. And now this should actually be able to run that function. So we'll simulate rolling a 10-sided dice. So you can see we got 4. And this is a really core concept in Python, which is importing functionality from external Python files. And this is like huge in Python, and this is seriously going to change the way that you create your Python files. So you'll notice like I didn't have to copy any functions or any variables or anything over into this file, and yet I was able to use all the stuff that was inside this useful tools file. So that is huge, and honestly, it's gonna save you a lot of time because you can write something once and then you can import it into your other files. And so that's really the basics of using modules. I mean, modules are very simple. A module is just any external Python file that you want to use some stuff inside of it. I want to show you guys a place where you can go to find a huge list of modules. So I'm going to go over here to my web browser, and I'm on this website. It's actually like the official Python docs. And basically all I did to get here was just type in list of Python modules in Google. And depending on the version of Python you're using, you're going to want to make sure that you click the right one. I clicked on the version 3 one. And over here on this page, you can see there's just a huge list of Python modules. And these are basically modules inside of Python that you can just access. So essentially there's like all of this awesome code that's already been written for you. And so if there's some sort of functionality that you want to have inside of your Python program, chances are there's a module in here that has that functionality. So there's all sorts of stuff you can do. I mean, if you just look through this list, like you'll see a huge collection of basically just, a bunch of either Python variables or Python functions, just, things that you can use to make your programs better. So here's what I would recommend, like head over to this page and just sort of look through a lot of these different modules, see what you can see. And honestly, like if you click on one of them, it'll bring you to a page that talks about like how to use it. It'll tell you like how to import it and just, some basics about it. And this is sort of like the list that's on the official Python docs, but here's the other thing. The Python community is huge. There's tons of developers who use Python, and you can actually find a lot of third-party modules. So if you just go online and, look up like Python module for doing X or Python module for doing Y, chances are somebody out there has already written a Python module to do what you're trying to do. So if you get good at using modules and you get good at looking for them and finding them, you can actually save yourself a bunch of time, because chances are that somebody's already written a module to do what you're trying to do, or like part of what you're trying to do. So now that we've taken a look at all these different Python modules, I want to just kind of dive in a little bit deeper into how we can actually use these things. So You'll notice here there's a lot of files, right? There's a lot of different modules that we apparently have access to in Python. But the question is, where are all these files stored, right? When I was over here in my program, for example, I was using this usefultools.py file. Like, I knew where that was. I created that file. I was directly involved in making it, and I just imported it over here. It was pretty easy, right? But what about all of these files, right? What about all of these modules over here? Like, where are all of these stored? And there's basically two types of modules here. There's built-in modules, which means they're just built into the Python language, so we kind of just automatically have access to them. And there's external modules. And a lot of these external modules are just stored in basically the same folder that we installed Python on our computer. So, for example, let's look at a couple of these, right? We have like base64, BDB, bin ASCII. Like, if I come over here, and you'll see I'm over here in my little file explorer, I have my Python project, which is draft. There's also this other folder over here called external libraries. If I was to click down on this and I come down here, you can see it's just the version of Python that I'm using. There's a folder here called lib, and this is a very important folder. This is basically storing all of those external modules. So you can see if I scroll down here, we have all of these different like modules, right? So here's that base64, here's BDB, right? A lot of these external modules are stored inside of this lib folder. And like I said, there's external modules. There's also a few modules that are just like built-in modules. They're not going to be stored inside of here. And you can actually tell, so for example, if I was to come over here and click on base64, it tells me where the source code is. So the source code's in lib/base64. We were able to see that, right? I saw that inside of my lib folder. This bin ASCII though, for example, if I click on this, you'll notice that this isn't giving me a folder because this is basically just like built into Python. So we don't have to worry about, locating that file. It's just kind of like, it just kind of works. So some of these are external, some of them are built in, and I want to show you guys, in addition to using these modules, right? So there's a lot of good stuff here, and honestly, you could spend, years and years just learning about all these different modules. But a lot of times you're going to want to use modules that other people have written. There's a lot of developers who work on Python and who write different modules. So there's a lot of useful modules out there that aren't included in this list, right? They're not going to be inside of this lib folder by default. And what we can actually do is we can install those external modules, those third-party modules that don't just come pre-installed with Python. And I'm going to show you guys how to do that really quick. So the first thing you need to do, obviously, is find a Python module that you want to install, that you want to download. And I have actually used one in the past, Python Docs. It's an external module that you can use to basically use Python to create Word documents, which is pretty cool. So you can like format Word documents inside of it. So I'm just going to look that up here in Google. I'm just going to type in Python Docs. And look, here's the thing. There's tons of these external modules. You don't have to use Python Docs. I'm just giving you guys an example. But really, if you just look up like useful third-party Python modules, there's going to be lists of hundreds of these things online. In my case, though, Python Docs has a website, and it basically just has like some installation instructions. So I'm going to come over here, and it tells me that I can install Python Docs using the command pip install Python Docs. So this brings us to something I want to talk to you guys about, which is pip. And pip is essentially a program. And actually, if you have a newer version of Python 3, it comes pre-installed with Python 3. And you can use pip to install Python modules. It's referred to as a package manager. And a package manager basically just allows you to like install, manage, update, and uninstall like different Python modules. So pip is extremely useful. And in order for us to install Python Docs, we're gonna have to use pip. So I'm gonna show you guys how we can do that. What I wanna do is open up the command prompt or the terminal on my computer. If you're on a Mac, you wanna open up your terminal. If you're on a Windows computer, you wanna open up your command prompt. I'm using a Windows right now, so I'm just gonna come down to the search bar and type in CMD, and this command prompt should come up. So I'm gonna click this, inside of the command prompt, we can actually use pip. The first thing we want to do is just check to make sure that pip's installed. And like I said, if you have a newer version of Python 3, pip should come just pre-installed, and it should just work in here. If you don't have a newer version of Python 3 though, you might have to install pip separately. And there's tons of instructions online on how to install pip. So I'm just gonna check to make sure that I have it. I'm gonna type in pip -- version, and this should spit out the version of pip that I currently have. So as long as we have pip, then we're ready to install an external or a third-party Python module. All I have to do is just say pip install, and now I just want to type in the name of the Python module. So in the case of Python docs, it was just Python docs like that. Now again, you don't have to install Python docs. I'm just doing this for this tutorial just to kind of show you guys how this is going to work. But what you want to do is go online and look up some third-party external Python modules. And generally, like I'd say 90 to 95% of the time, you're going to be able to just install them using pip. In the off case that you can't install them using pip, chances are there'll be like some detailed installation instructions. But I would say for the most part, any like legitimate Python module is going to be able to install it using pip. So over here, I'm just going to say pip install and then the module name. So Python-docs. And when I click enter, this is going to go off and install Python docs for us. So I'm just going to click enter, and it's going to go off and install everything we need for Python docs. So you can see we successfully installed Python docs 0.8.6. So I'm going to show you guys where exactly this got placed. So normally when we install a external third-party module, it's going to get put inside of this lib folder. But it's going to get put inside of a special folder in here called site packages. So site packages is a special folder, and if I open this folder, you'll see now we have this docs folder, and we also have this Python docs 0.8.6 py3.6.egg info folder. So these two folders are basically included in that module installation. So you can see this docs folder has a bunch of different Python files and has a bunch of stuff in here that we can use. So if I wanted to use this inside of one of my programs, I'm just going to refer to the name of the module. So in our case, it's just going to be docs. So I used Python docs in order to install it, but we're going to use docs if we want to import it. So I could come up here and I could say import docx, and now I can actually use it. So I could just say like docs dot whatever, and you can see there's a bunch of different stuff down here. There's like a document part, image part. There's a bunch of stuff that we can use with this. And obviously, depending on the Python module you install, there's going to be different instructions. But you can see it got stored down here in this site packages folder. If I wanted to remove this, I could use pip to do it. So I could just say pip uninstall, and we could just again say the module name, so Python docs, and pip will now uninstall this on our computer. So if I was to go back over to this folder, you'll see that those two, that docs folder and then that other folder disappeared. So they're no longer here, and I'm actually not going to be able to use this anymore. So that's sort of the ins and outs of using modules. Now again, there's tons of these modules, and I can make dozens and dozens of Python courses covering each one of these modules. The built-in modules, the modules that are included by default, and external modules. There's tons of these things out there. And really, as a Python programmer now, what you can do is you can go out and play around with these different modules. I showed you the ins and outs of installing them, and you can use pip to install all these different modules. And you can make sure that you have them by checking the site packages folder or the libs folder. But really now it's on you to just kind of go out and use these modules, and don't shy away from this, because modules are a huge part of Python, and you're definitely going to want to include them in your Python stack. In this tutorial, I want to talk to you guys about classes and objects in Python. Now, classes and objects are extremely useful in Python programming, and they can help you to make your programs more organized and more powerful. So when we're in Python, we're dealing with all types of data, right? And a lot of times when we're writing programs, we're going to have to work with different types of data. And there's essentially like a few basic types of data we can deal with, usually things like strings, so like plain text, numbers, and Boolean values. Those three are kind of like the main types of data that you're going to be working with in Python. And we have all sorts of structures we can use to store that data, things like lists or dictionaries. But here's the problem, is that not all information, not all data, not all things can be represented using strings, numbers, or Booleans, right? There's a lot of things in the real world that we can't represent in something like a string or just a number, right? In other words, think of something like a phone or a computer or a person, right? You can't really represent those things in like a string or a number. In other words, like the data types that we have available to us in Python can't cover that. And so what we can do with classes and objects is we can essentially create our own data types. So I can create my own data type for anything I want in Python. So I could create like a phone data type, and it could represent a phone. So I could store all the information I would ever want to know about my phone inside of that data type. And in Python, we could create a class for it. And essentially what a class is it's just saying, hey, here's another data type that we want to use in Python. So with a class, you can essentially define your own data type, and it's super awesome. And classes are extremely useful. Classes are used in almost every single major programming language out there. So in this tutorial, I just want to give you guys a basic introduction of classes and using them inside of Python. So let's say that I'm writing a program and I want to represent a student inside of this program. So maybe I'm writing a program for like a college or a university. Let's say that in this program, I want to model a student. Like I want to model a real world object and I want it to be a student, right? Well, we don't have a student data type, and I can't really represent a student in just a single string or a number. So what I can actually do is I can create a class for a student, and I'm basically creating like a student data type. So I'm going to show you guys how we can do that and create our student class. So over here, I'm just going to make a new file. We'll just make it a new Python file. So I'm just going to call it student.py. And inside of this student.py file, I want to create a student class. So the way that I can do that is just by typing class. And now I want to type the name of the class that I want to create. So in our case, we're going to create a class called student. So I'm just going to say student, and now we're going to make a colon. And now everything that goes inside of here is going to be inside of our student class. So everything that's indented like this will be considered a part of our student class. And basically what we can do inside of this student class is we can define a bunch of attributes about a student. So essentially what I'm doing is I'm like modeling a student. I'm creating our student data type. And I can use things like strings, integers, and Booleans in order to map out what a student should be and what a student should have. So I want to create something called an initialize function. And the way I do that is just by typing out def, and I'm just going to type 2 underscores, and then the word init, and then 2 more underscores. And you also want to type out open and close parentheses, and inside of those parentheses, we want to type out self, and then we want a colon after that. What I can do inside of this initialize function is I can basically map out what attributes a student should have. So we can essentially define like, hey, here's the student data type in Python. So what I want to do is add in certain attributes after this self. So I'm just going to say self, a comma, and now we can start thinking about, what values will represent a student inside of our Python program. So if I'm thinking something like name, right? So every student in our program should have a name. They also might want to have a major because they're in college. They probably also will have a GPA, so their grade point average, like how they're doing in school. And let's define one more thing. Let me think. Why don't we make a Boolean, and it's going to be called is on probation. And this will basically tell whether or not the student is on probation. So essentially what I'm doing inside of this initialize method, inside of this init function, is I'm defining what a student is in our program. And so in this program, a student has a name, it has a major, it has a GPA, and it has a value that determines whether or not it's on probation. This right here is the student data type. So if I'm representing a student inside of my program now, it has all of these attributes associated to it. And that's basically what I'm doing up here. Now, inside of this initialize function, we actually have to do something. And basically what I want to do is assign some values. So I'm going to be writing out some stuff, and this might not make total sense right now, but this is going to make sense in a second after we create our first student object. So just stick with me right now and just basically know that we have to do what I'm doing over here. So I'm just going to say self.name is equal to name, and then I'm going to say self.major is equal to major, self.gpa is equal to GPA, and I'm going to say self.is on probation is equal to is on probation. So again, this might not make a whole lot of sense right now, but in a little bit, this is gonna make total sense. So now that I have this student class defined, I can actually use this class inside of my other files. So I'm gonna come over here into this app.python file, and this is just my main file. And so I actually wanna create a student, right? So in that student class, we defined the student data type, and we basically said like, hey, a student has a name, a major, a GPA, and it says whether or not they're on probation. That's like the template for what a student is. But we can actually create a student. So we can create an actual student and give it some information. And that's called an object. So this student class over here is basically defining what a student is. So a class is just like an overview of what the student data type is. An object is an actual student. So it's an actual student with a name, a major, and a GPA. It's not just this template anymore, it's actually like a student that we're representing inside of our program. So in order to use that student class and create a student object, I actually need to import that. So all I have to do over here is just say from student, and this is referring to this student file. I can say import student. And basically what this is saying is from the student file, I want to import the student class. So even though these are both student, they're referring to different things. So this is referring to the file, and this is referring to the actual student class. So now that we did this, we can create a student. So you can create an object of a class a lot like you would a normal variable. So I can just give it a name. I'm gonna call this student1, and I'm just gonna set it equal to student, and I'm gonna make an open and close parentheses. And now inside of this parentheses, I wanna give this student a name, a major, a GPA, and an is on probation value. So I'm gonna say, we'll just create a fake student. So I'll just say his name's Jim, and he's studying business, and we wanna give him a GPA. So maybe he has like a 3.1. And finally, we want to say whether or not this student is on probation. So why don't we say false? So basically what I'm doing is I'm saying that I want to create a student. So I want to actually create a student object. And remember, an object is just an instance of a class. So the class is like an overall template. It defines what a student is. But an object is an actual student with actual information. So we could call student1 now, this is a student object. So I just want to show you guys what this student object actually is and what we can do with it. And then I'm going to talk some more about that init function from before. So over here, I'm just going to make a print statement. And inside of here, I just want to print out student. And what's cool about this student1 object is I can actually access each of the attributes from inside of this object. So if I wanted to get the name of the student, I could say student1.name. And now this is actually going to print out the student's name. So over here, you'll see it prints out Jim. If I wanted, I could print out the student's GPA, and it's going to print out the student's GPA, 3.1. So now that I created this student object, I can actually access the information about the student. So essentially, I've just created a student data type. So I could create as many of these students as I wanted. If I wanted, I could create another student. We could call it student2. And essentially, we do the same thing. We just give it different information. So we could say like Pam, and her major is art, and she has like a 2.5, and let's say that she is on probation. So now I have another student, student 2. So if I wanted, I could access information about that student. We could say like student2.gpa. And now this is giving me the GPA of student 2. So basically what I did was I created a student data type and I created student objects, and now I'm able to represent a student inside of my program. So let's talk real quick about all this stuff over here because I didn't really explain it. Basically what's happening is when I come over here and I say student and I'm passing in all of these different values, those are getting passed into this init function. So remember, I passed in a name, I passed in a major, I passed in a GPA. When we create that student, we're actually calling this function. And when I pass in the name, the major, and the GPA, those values are actually getting stored over here in this name, this major, this GPA, etc. Right? So I'm giving this student object all of that information. And down here, what I'm doing is I'm saying self.name is equal to name. And basically what this means is the actual object's name is going to be equal to the name that they passed in. So self.name is an attribute of student, right? So the student is storing a name, the student is storing a major, the student is storing a GPA. But that's different from this name, this major, and this GPA. Remember, these are all just values that I passed in. They're just parameters. And so I need to take the values that I passed in and I need to assign them to the actual attributes of the object. So I need to say, okay, the name of the student is going to be equal to the name that we passed in. One more time. The name of the student object is going to be equal to the name that we passed in. The name of the student's major is going to be equal to the major that we passed in. The student's GPA is going to be equal to the GPA that we passed in. That's basically what's happening here. So when I say self, it's referring to the actual object. So over here, when I'm creating this student object, I'm giving it all of this information. It's taking that information and storing it as attributes for the object. So hopefully that makes sense. I think that's about as clear as I can make it. But the point is that now we have a student data type. So now I can represent a student inside of my Python program. And that's like super powerful. And what's cool about classes and objects is you can do this with anything. So in this example, we created a student class and then we created student objects off of that. But I could model any real world entity into this program. I could model something like a phone, or I could model like a water bottle, or I could model, a keyboard, right? I could model anything that I wanted inside of my program. I could just give it certain attributes, right? And so that's what's cool about classes is we can model real world objects and we can create our own data types. In this tutorial, I'm going to show you guys how to build a multiple choice quiz in Python. So basically we're going to set up a little multiple choice quiz and we'll have the user take the quiz, and as they take the quiz, we'll keep track of their score, and then at the end we'll tell them how they did. So this is going to be a pretty cool video. I'm excited to show you guys how to do this, and we'll get to use things like classes and if statements and loops in order to build this program. So we're going to use a lot of cool stuff in Python. The first thing I want to show you guys, I actually did this before I started the video. It's this little array. It's called question prompts. And I basically just wrote out all the questions that are going to be, or I shouldn't say the questions, I wrote out all the question prompts that are going to be inside of my multiple choice quiz. So the first one just says, what color are apples? And the answers are red, purple, or orange. The next one is, what color are bananas? The options are teal, magenta, and yellow. And the third question is, what color are strawberries? And the options are yellow, red, and blue. So this is obviously a very, very easy multiple choice quiz, but I just kind of wrote out the questions beforehand so I didn't have to spend time doing that. So let's talk about how we can build a multiple choice test. Well, the first thing I want to think about is how can I represent the questions in the test, right? Over here we have the question prompts, but there's actually two parts to a question when you think about it. There's the prompt, in other words, like the actual question itself, and then there's the answer to the question. And both of those attributes need to be kept track of, right? I need to keep track of what we want to ask, and I need to keep track of what the answer is. So what I'm actually going to do is create a question class. So I'm going to create a little data type for questions. And inside of that question class, we'll be able to store the question prompt, and we'll also be able to store the question's answer. So I'm just going to come over here to my folder, and I'm going to make a new Python file, and we're just going to call this question.py. So we'll call it question.py. And inside of this question.py file, I'm going to make a class. So I'm just going to say class question, and I'm going to put a colon here. So inside of this question class, we want to define it in an initialize function. So I'm going to say def 2 underscores init 2 underscores, and then we're going to type out an open and close parentheses self and then a colon. So after this self, we want to define the different attributes that will describe or that will be included in a question. So we're going to include a prompt, and we're going to include an answer. So every question will have a question prompt and a question answer. And now down here, I want to take those values and assign them to the actual class object. So I'm going to say self.prompt is equal to prompt, and I'm going to say self.answer is equal to answer. So now we have a question class set up, and we can store all the information we need about a question. So what I want to do now is go back over to my app.python file, and we're actually going to create an array of questions. So I have over here these 3 prompts, and I'm actually just going to create another array. So we'll just call it questions, and I'm just going to set it equal to 2 open and close square brackets, and we're going to start creating question objects. So I can just say the first element in this questions array will be a question, and we want to pass question prompts 0, and the answer to the first question was A, red, green. That's the color of apple. So I'm going to pass that first question, and I'm also going to pass the answer, which is A. And you'll see down here I'm getting an error, so it's saying unresolved reference question. So actually what we need to do before we can create these questions is we need to import this question class. So I'm going to come up here and say from question import question. And so now down here in this questions array, we're not getting that error anymore. So we created one question object, and I'm just gonna create a couple more for these other ones. So I'm just gonna copy this one, and we will paste this down here. All right, so now we're creating 2 other questions, and these ones are gonna be 1 and 2. And the answer to the second question is C. And the answer to the third question, I think it's B. Let me look. Yeah, so it's C and B. All right, so essentially what we're doing is we're creating 3 questions. Each one is getting a different question prompt, and they're each getting different answers. So now we have an array of questions that we want to ask on our test. So the next step is to actually write a function that will run the test, right? It has to ask the user the questions, and it has to check to see if they got the answer right. So down here, lower in the file, let's create a function. So I'm just going to say def, and we'll call this run test. And inside of this parentheses, we're going to take one parameter into this function. We're going to take a list of questions. So I'm just going to say questions. So this is basically going to be a list of question objects that we want to ask the user. So once I'm in here, all I want to do is loop through all the questions. So I want to loop through each question. I want to ask it to the user. I want to get the user's answer, and I want to check to see if it's right. And we need to be able to keep track of how the user does through the test. So I want to create a variable called score, and I'm just going to set it equal to 0. So every time the user answers a question right, we'll increment this score variable. All right, so what I want to do is, like I said, loop through all the questions in that questions array. So I'm going to create a for loop. I'm going to say for question in questions. So in other words, for each question object inside of this questions array, I want to do something. And basically, the first thing I want to do is ask the user the question. And I want to store their response inside of a variable. So I'm going to make a variable down here called answer. And this is going to represent the user's answer to the question. And I'm going to set it equal to input and I need to give this a prompt. So I'm actually going to give this the prompt for the question. So I can just say question.prompt. So now I have the answer that the user entered in, which is stored inside this variable. So we want to check to see if they got the question right. And I can do that using an if statement. So I can say if answer, and this refers to the student's answer, is equal to question.answer. So I'm checking to see if the answer that the student gave is equal to the answer of the current question that we're asking. And if this is true, then I just want to increment score. So I'm going to say score plus equals 1. And this basically just means we're adding 1 to the score. So the last thing I want to do inside of this function is just print out the result. So I want to print out how the user did. So down here, I'm just going to say print, and I'm basically just going to print out like, hey, you got like 2 out of 3 questions, or you got 5 out of 6 questions right, or you got 0 out of 10 questions right. We'll just print out how they did. So I'll just say you got, and now I want to print out how many questions they got right. So this is just going to be the score. And in order to print a number alongside of a string like this, I'm going to have to say str and then type in the number. So we'll say str score. So we'll basically say you got however many they got right out of, so we'll use this little /, and now we'll just say how many questions there were. So we can say, and again, we're gonna have to convert this to a string because it's gonna be a number. So we can say string, and then we wanna figure out how many questions were in that questions array. So I can say len, and inside of here, we can just say questions. So this is kind of like this long statement just to print out how many questions there were. So then over here, I'll just say correct. All right, so now we have this print statement, and it's just going to be printing out how many questions they got right. So let's see if this works. The last thing I need to do is just call this run test function. So I'll say run test, and I'm just going to pass it that questions array that we created before. So we created this questions array with all of these question objects inside of it. I'm basically just going to pass that into this run test function. So now let's run our program and see how we did. Hopefully we don't get any errors. There's a lot of code there, so it's possible that we might. Okay, so it says, what color are apples? This is a tough one. All right, let's put A, so we'll get the first question right. What color are bananas? Let's get the second question wrong. So I'm gonna say B, bananas are magenta. And we'll get the third question right. So it says, what color are strawberries? I'll just put B because that's the right answer. So now you'll see that our program prints out, you got 2 out of 3 correct. So not only did it ask us all the questions and get our input for each question, but it also kept track of our score and it printed it out. So why don't we run through the test one more time, and we'll just like get 2 wrong this time. So I'll get this one wrong, I'll get this one wrong, and I'll get this one right. So now it says you got 1 out of 3 correct. So it's able to actually grade our test. And what's cool about the program we just wrote is if I wanted, I could add another question into here and it would automatically be able to ask it. So it doesn't matter how many questions we put in here, it's just able to ask it. And so really the point I was trying to make with this whole video was just how we can use something like a class in order to model a real world entity. So for example, we created this question class and we were able to store all the information about a question that we could ever need. So we were able to store like the prompt and the answer. So we created our own question data type, and then we were able to create a bunch of different questions, pass it into this run test method, and it was able to grade the test and just run the test really easily. So that's kind of the point. So hopefully this makes sense. You know, this was a lot of code, so if you don't fully understand what I did, go back, watch the video, you know, try it a couple times on your own and see if you can create your own multiple choice test. In this tutorial, I want to talk to you guys about class functions in Python. So a class function is essentially a function that we can use inside of a class, and it can either modify the objects of that class or it can give us specific information about those objects. Over here, I have this student.py file. And inside of here, I created a student class. So I just had a class student, and I gave this student a couple of different attributes. I gave it a name, a major, and a GPA. So I can give this student all of this information. So when I create a student object, it'll have all of that information in it. Now over here on this app.py file, I actually created two students. So student 1 is Oscar, who is studying accounting, and he has a GPA of 3.1. Student 2 is Phyllis, who's studying business, and she has a 3.8. So what we can actually do is we can use functions inside of these class files. So I could actually define a function inside of this student class, and then all of my student objects could access it. So for example, I could come down here and create a function, and let's say we wanted to create a function that told us whether or not this particular student had honors. So whether or not they were on the honor roll, right? Basically, like, are they like a really good student? So I could define a function called onHonor and basically what it's gonna do, it's going to tell me whether or not this particular student is on the honor roll. And let's basically just say the rules for being on honor roll is you have to have a GPA of 3.5 or above. So if your GPA is 3.5 or above, that means you're on the honor roll. Well, over here, I could actually write the code for that. So I could say if self.gpa, and when I say self over here, this is referring to like the actual student's GPA. And you'll notice over here, I have to pass that in as a parameter, and that always has to be the first parameter. So I could say if self.gpa is greater than or equal to 3.5, then we can return true, because this student is on the honor roll. Otherwise, else, we can just return false, because if their GPA isn't above a 3.5, then they're not on the honor roll. So that's essentially our little onHonor function. And you can see it's a very small function, but it provides a service to the objects of this class, right? It allows the objects of this class to figure out whether or not that current student is on the honor roll. So over in this app.py file, I could just print out that value. So I could say print, and I'm gonna see if student 1 is on the honor roll. So now when I run this, you'll see it should print out false. And it's printing out false down here because student 1 only has a GPA of 3.1. If I was to do the same thing on student 2, student 2 has a GPA of 3.8, so we should return true. And that's exactly what happens. So essentially a class function is just a little function that can be used by the objects of the class. And I would say this is a pretty good example of like what a class function should be doing. It should be like giving us information about the class, or it could also be like modifying information about the class. And so that's the basics of using functions in classes. I mean, this is a pretty simple tutorial, but I really just wanted to introduce you guys to the concept of putting functions inside of classes. This is gonna be really useful. And if you're making a class, you always want to think about like what functions can I put inside of here that will, you know, essentially help the user to either figure out information about the object or modify different values in the object. In this tutorial, I want to talk to you guys about inheritance in Python. Now, inheritance is basically where we can define a bunch of attributes and functions and things inside of a class, and then we can create another class and we can inherit all of those attributes. So I could basically have one class that has all the functionality of another class without having to physically write out any of the same methods or attributes. So if that's confusing, don't worry. I'm gonna show you guys exactly what this is in this video. So let me show you about some stuff I have set up over here. I created this class called Chef. And over here we just have this class Chef. And inside of this chef class, we have 3 functions. So this chef can do 3 things. The chef can make chicken, the chef can make salad, and the chef can make a special dish. And whenever the chef makes a dish, he basically just says, the chef makes a chicken, or the chef makes a salad, or the chef makes barbecue ribs for this special dish. It's basically just saying whatever the chef is doing. So if I was to come over here to my app.python file, you'll notice that I'm importing the chef. So I'm basically allowed to use this chef class now. And I can say my chef is equal to chef. So I'm creating a new chef. So now if I came down here and I said my chef dot make chicken, when I run my program, now it's gonna say the chef makes a chicken. If I said make special dish and I run the program, now it's gonna say the chef makes barbecue ribs, right? Because that's the chef's special dish. So I have this really awesome chef class and it works really well. But let's say that I wanted to create another class to model another type of chef, right? So this chef class is just modeling like some generic chef, right? We're representing some generic chef in our program. But let's say that I wanted to create a class that modeled a different type of chef. For example, let's say we wanted to create a class that modeled a Chinese chef. So instead of just a normal chef, this is a Chinese chef. Well, I actually created a file over here called ChineseChef.python. So we could actually use this ChineseChef.python file to create our Chinese chef class. So I'm just gonna say class, and over here I'm just gonna say Chinese chef, and basically I just can define everything that the Chinese chef can do. But let's say that our Chinese chef can do everything that our generic chef can do. So the Chinese chef is like a special chef, right? It's a very specific type of chef. But let's say that this Chinese chef can do everything that the normal chef can do. So the Chinese chef can make chicken, can make salad, and can also make a special dish. Well, if I wanted to give this Chinese chef all of that functionality, I could just come over here and I could copy all of these functions and I could paste them in here. And so now the Chinese chef can do everything that the other chef can do. But let's say that in addition to all of these things, the Chinese chef can also make a special dish called fried rice. So I could say def, and we could say make fried rice. So the Chinese chef has this extra function which allows it to make fried rice. And over here we could just say the chef makes fried rice. And let's also say that the Chinese chef has a different special dish. So instead of making barbecue ribs, the Chinese chef makes orange chicken. All right, so now we have our Chinese chef class set up, and you'll notice that it can do everything that the normal chef could do. So let's go back over to our app.python file, and I want to create a Chinese chef object. So instead of importing from chef, we're gonna just import from Chinese chef. So I'll say Chinese chef, and we're gonna import Chinese chef. So let's go ahead and make a Chinese chef object. So down here, I'm gonna make one, and I'll just say and then my Chinese chef, we can print out this special dish. So remember, the Chinese chef can do everything that the normal chef could do. So if I say my Chinese chef dot make special dish, when I run this program, you'll see the regular chef is making barbecue ribs and the Chinese chef is making orange chicken. So everything works out. And this Chinese chef also has an extra method called make fried rice, and you can also make fried rice. But here's the problem, right? When I go over here to this ChineseChef.py, when I wanted to use all of the functionality that was inside this chef class, I actually had to copy and physically paste all of these functions down into this file, right? And that's kind of a drag. I mean, especially like, imagine if this chef had like 20 or 30 of these different functions in it. Well, I'd have to copy and I'd have to paste all of those inside of this Chinese chef. And this is where we can use something called inheritance. So instead of having to copy and paste all of these functions, I could just inherit these functions from that chef class. And in order to do that, I can actually just get rid of all of these, and I can come over here and right next to where I'm saying class Chinese chef, inside of parentheses, I can say the name of the class that I want to inherit from. So I could just say chef. And I'm also gonna have to import this. So I'm gonna come over here and we'll say from chef, import chef. So basically what this is saying is inside of this Chinese chef, I wanna be able to use all of the functions that are contained inside of the chef class. So I'll say that one more time. Inside of this Chinese chef class, I wanna be able to use all of the functions that are inside of this chef class. So by using inheritance here, I'm actually able to come over here to this app.py file, and now I'm still able to execute, for example, like the make chicken function. Even though I didn't specify the make chicken function in here, I didn't write it out, I can still run this program and the Chinese chef will still be able to make chicken. So when I run this program, you'll see down here it says the chef makes chicken. And that's because I inherited the make chicken method from the chef class. But here's one thing that got messed up. If I come over here and I say make special dish, remember the Chinese chef special dish was supposed to be orange chicken, but now the Chinese chef is gonna be making barbecue ribs because I inherited this make special dish function from this chef class. And so what I can actually do is I could come in here and I could override that make special dish class. So I could say def make special dish, and down here I can just override it. So I could say the chef makes orange chicken. And now when I go over here and I run this make special dish function, now the chef's gonna be back to making orange chicken. So the Chinese chef will make his special dish. So that's basically what inheritance does. It allows me to inherit functionality from an existing class into the new class, and I can actually just inherit all of it without having to write it out. So I didn't have to write out make chicken and make salad inside the Chinese class, but the Chinese chef can still make chicken and salad because it inherited that functionality from the chef class. In this tutorial, I want to talk to you guys about the Python interpreter. The Python interpreter is basically a little environment that we can use to execute Python commands. So it's kind of like this little sandbox environment where we can test out and try out different Python commands or different Python functions in a very safe and neutral environment. So it's kind of like a quick and dirty way to write Python and try different things out. And the way we use the Python interpreter is by opening up our command prompt. Now, if you're on Windows, there's a program called Command Prompt. If you're on Mac, there's a program called Terminal. And basically you need to open that program in order to use the Python interpreter. So I'm here on a Mac, but if you're on a Windows, you can essentially do exactly what I'm doing just inside of the command prompt. So on Mac here, I'm just gonna search for my terminal. If you're on Windows, you can just search for like CMD or command prompt and it should pop up. So the terminal is basically an environment on our computer where we can interact with the computer and do different things without a graphical user interface. So normally when we interact with the computer, we're using things like buttons or windows, and where we can move stuff around. We can basically just like interact with the computer with graphics. But the terminal or the command prompt is a place where we can interact with the computer using text commands. So I'm not going to get too much into what the terminal and the command prompt are, but that's essentially what it is. So inside of here, we can use the Python interpreter. And the Python interpreter is basically just a little program that, like I said, we can write, sort of Python in. So generally, all you have to do is go over to your terminal or your command prompt and type in Python 3. And since we're using Python 3, I'm going to type Python 3. But you can also just type normal Python, and I'm pretty sure that gives you Python 2. Now, here's a quick disclaimer. On Windows, you may run into a problem where you can't use this Python 3 command, and it's possible that if you're running into that problem, Python 3 hasn't been added to your Windows path variable. And basically what that means is your computer doesn't recognize the command Python 3. If that's the case, all you have to do is just go and Google how to add Python 3 to your Windows path variable. It's really easy. I'm not going to get into it in this video just because it's kind of outside the scope, but if you're running into that problem, that's probably it. It's not on your Windows path variable. So just Google around for that and you should be able to find an answer. But I'm going to type Python 3 and I'm going to click enter, and it's going to open up this cool little thing down here. So you can see it basically just says like, here's the version of Python. Now, I'm just gonna enter so we can have some like new lines here. But down here, this is the Python interpreter. So we can write Python code in here and it's gonna work. So I could, for example, I could write like print, and inside of here I could print like hello world. And when I click enter, you'll see that it prints out hello world. I could create a variable. So for example, I could say like num1 is equal to 10. I could say num2 is equal to 90, and then I could print out num1 plus num2, and it's gonna be able to do that for me. I could also use something like a function. So I could define a function in here. We could make a function that's called say hi, and it'll take a name parameter. And you'll see here, when it saw I wanted to create a function, it put these 3 little dots, and I can indent in and we can write the code for our function. So I could say like print hello plus name. And now I have a function called say hi. So I can break out of this by just entering again. And I can call the function. So I could say hi, and we'll say hi to me. Hi, Mike. So now it's gonna say, hello, Mike. So I can use a function. I could use something like an if statement, you know. I could say, I could use something like a for loop. We could use while loops. I mean, we can basically use all of the basic like Python commands and, you know, inside of this Python interpreter. And like I said before, it's essentially just an environment where you can test out Python code. Now, this is not a place where you want to write like any serious Python scripts. So if you're like designing and writing a Python program, I would not recommend doing it inside of this interpreter. It is, it's not a very intuitive environment. It's pretty much just set up for some quick and dirty tests. Like if you need to test something out, great. This is a perfect place for it because you don't have to set up a file. You don't have to use like some IDE. You don't have to execute a file. You just go in here, it's quick, it's dirty, you get it done. But if you're writing like an actual program, you definitely want to use a text editor. The text editor, it's just going to be way more organized. Everything's going to be a lot clearer, and you're not going to get confused with like where stuff is and what you have. So that's the basics of the Python interpreter. You know, in the course, I haven't really been using it at all, just because I think it's a lot easier to teach when we're inside of a file than inside of here. But, you know, don't count this guy out. The Python interpreter is awesome. A lot of people use it, and it's great if you just need to test, you know, little bits of code out without having to set up some huge environment. So Python interpreter, definitely awesome. I would play around with it, you know, have some fun and take advantage of it. Hey, thanks for watching. If you enjoyed the video, please leave a like and subscribe to Draft Academy to be the first to know when we release new content. Also, we're always looking to improve, so if you have any constructive criticism or questions or anything, leave a comment below. Finally, if you're enjoying Draft Academy and you want to help us grow, head over to draftacademy.com/contribute and invest in our future.